Hi, my name is Melissa Toby,
And my name is Amanda Fernandez.
and we are going to be researching the game of single pile NIM. Single pile NIM is a mathematical combinatorial game which involves two players taking turns removing stones from a pile until one of the players is not able to make a move. The last player to make a legal move will be named the winner. Players can remove a certain amount of stones at a time depending on the size of the set. This will make a lot more sense once we show you an example of the game getting played. Let's take a set of s equals 2 and 3, and we will start with 14 stones. So with a set of 2 and 3, that means that we can either take away 2 stones at a time or 3 stones at a time. I'm going to be player 1 in orange, and Amanda is going to be player 2 in green. So I'll go first. I'm going to take away 2 stones.
And I'm going to take away 3 stones.
So it's my turn again, and I'll take away 3 stones.
And I'm going to take away 2 stones, leaving 4 stones left.
Now, when I see that there are 4 stones left, if I were to take away 2 stones, then that would leave Amanda to take away 2 stones, and she would win. So I'm going to take away 3 stones, which will leave her with only 1 stone left, which is not a possible move in this set, so she will lose. Player 1 will win this game.
There's actually a strategic way to play this game to ensure that you will win. If we work backwards, which in math we call backwards induction, we will be able to determine if you will be able to win or lose at each token. Let's look at token 1.
So that's here.
If you are the player left with 1 token, you will lose because you can only take 2 or 3 tokens. We actually saw this happen to player 2 in the game we played. We will indicate a losing position with a 0. Let's look at token 2. If it is your turn, you can take 2 tokens and win. We will indicate a winning position with a 1. The optimal strategy of this game is to place yourself in a winning position as early in the game as you can.
So if we keep working on this, we would see that if there were 3 stones left and you took all 3, you would also win. So that would get a 1. If you were at 4 stones, you could take 3 stones and leave the next player with 1 stone, so they would be in a losing position. So 4 is actually a winning position. If we look at 5 stones, then I could take 2 stones right here, but that would still leave player 2 with 3 stones, so they could still win. If I took 3 stones, that would leave player 2 with 2 stones, and they would win. So 5 is a losing position. Same thing with 6. If I were to take 3 stones, that would leave player 2 with 3 stones, and they could win. And if I took 2 stones, that would leave them with 3 stones, and I would only have 1 stone left, so I would lose. This is a losing position. This pattern will continue throughout the game.
Playing this game has led us to an open problem we are trying to solve. Given an n number of stones, we want to know if in a given subtraction set of A, B, and C, is there a recursion formula that will allow player 2 to win every single time?
So we're going to look into that, and hopefully we'll get back to you with some results.